scientific processes and discoveries. And for this, we will be using the images that we took during the first part. But I would not continue because we have a much more expert on the issue, Mr. Dr. Fraser Lewis, who is a member of the Fox Telescope project based in South Wales. He this project provides telescope time free of charge to educators and teachers throughout the world, as well as providing resources to support the observations. And Fraser, the floor is yours.
Nikos, thank you. Gustavo, were you going to go first on showing SalsaJ? Is that Gustavo? Your mic is off.
I'm sorry. Yeah, I'm double tasking here. I was setting up the channel. So yes, that's the idea. We are going to present SalsaJ, and I just was talking to Fraser that maybe it would be more interesting if I show you the basics of this software, and then later Fraser will show us some data that were acquired during last week's live observing session. So that's the plan for this afternoon. Rosa Doran was we were expecting her to be here also, but she could not join due to a last minute issue. But she'll be back in the next meetings, in the next webinars. So what is SalsaJ? So SalsaJ is a software that was developed for making possible to everyone to open and process and analyze images taken with telescopes. So in telescopes, you attach cameras, but these cameras, if they are astronomical cameras, they do not save the images in, in standard format as we are using, like JPG or PNG, those standard image files formats that you are using. Astronomical cameras record the images in a specific format that is called FITS, F-I-T-S, which is the acronym for Flexible Image Transport System. And this has been for a long while in the astronomical community. This format has been used, I don't know, maybe more than 40 years. And then it is standard format for all astronomical cameras. This makes things easy because I can access, images that are taken with any telescope in the world from now or from 10 years ago or for 20 years ago. They are all in the same format, but they present a small difficulty that usually the computers people have access, non-scientists, they don't have the software to open these kind of files. So that's where SalsaJ comes in, because it allows us to open these files and work with them. And this is very powerful. So I'm going to start showing some of the features of SalsaJ. SalsaJ can be downloaded from the Hands-on Universe website. It is also available on the European Hands-on Universe website, but the site is offline for some time. It will be back, but it hasn't been fixed yet. So meanwhile, we have to use the handsonuniverse.org link. I will put the link on the chat later when I'm finished talking. But the idea is that all of you can download and install SalsaJ. It's free. It works on all operating systems, and it's very easy to use. It requires Java, so you need to have Java on your computer to run SalsaJ, and that sometimes can be a bit tricky because the computer sometimes don't know that SalsaJ is meant to be open with Java. But in any case, it's quite easy, straightforward to make it running on your computer. And this software was developed more than 10 years ago, so the interface is very simple, as you can see in the screen. we have this yellow window with some icons, and there's also a menu on the top. So I'll probably have to share again my screen very soon to do some of the procedures. But if this yellow window, we can, for instance, open a file. So when we click open, then we have the option to select the images. So in my computer, it is stored in a folder here called data. And when you download SalsaJ, you will see that there are many different folders that come with the software. These are meant to be used with the activities that are along SalsaJ. By the way, Fraser, can you see the other windows? No, right? Now you see only my camera.
Only see you right now, yeah.
Yeah, okay. So I'll stop sharing and share again, because I think I have to share my whole desktop. So let me stop sharing and try again, because okay, sorry. So that's the problem of double tasking. I hit the wrong button. So instead of hitting share screen, I hit end, but we are back live now. So I'm going to share my desktop here, my whole desktop. So welcome back, Fraser. We had a minor issue here. So now I'm screen sharing, and
You're kind of screen sharing Zoom at the YouTube.
Yeah, and now I'm going to be back on SalsaJ. So you're going to see. Let me minimize it here. Okay. So yes, I have to open this. Okay. So now we are going to open the data. So in the pictures folder, and then on data. And now I think we can all see the folders. And I will start with some general images about nebula, or maybe the moon. Maybe it is good to start. So here I'm going to show a picture of the moon. So this is a picture of one of the craters on the moon that is called Copernicus. And this image, we can see this famous crater that is one of the largest on the near side of the moon. And we can play with the image. So one of the things that we can do is that you can make the image brighter or darker. That is done with the contrast. So when we hit this button here on the top right, on the top row on the right, we can control the brightness of the image. So here, if we play with the sliders, we can have the images to be brighter or darker, so we can see better what is going on. We can also control the brightness as a whole and the contrast. If you don't know what to do, we have the auto button, which will automatically set up the image. And if you are not satisfied with the result, you can click on reset, and it will return to the default format. So here we have this image of the moon, and there are a lot of things that we can do in the image. So for instance, we can zoom in the image, and then we can see it closer. And if I zoom in too much, we start seeing the pixels. So here I have the very magnified image of the crater, and you start seeing the individual pixels. So this is what an astronomical camera looks very, very close. If you could see the sensor, you would see the individual pixels. So here we have the individual pixels of the images. And when I move the cursor around the image, we can see here on the yellow window some numbers changing. So here you can see X, Y, and value. What does this means? This means the position of the pixel, which is the row and column, X and Y, and the value is a measure of the brightness. So the brightest the pixel, the highest the value. So here, when I move the cursor to a very bright pixel, it will read like 49,000, 50,000. And if I move here near the crater, the value drops. So this is useful to check if you have lots of light coming from that region in the image or just a little bit. Another thing that we can do is that we can move. There's this hand icon that you can move the image around. And finally, we can use some tools. I'm going to show this tool that is the line selection. So when you click here, it will draw a line. So we can use this tool here to draw a line over the image. And as you can see on the yellow window, on the main window of SalsaJ, there are numbers changing again. So now what these numbers show, they're showing the position of the cursor in X and Y, the angle. So if the angle is 0, it's an horizontal line. If the angle is 90 or 270 or minus 90, it's a vertical line. So this will show me the position and angle of the line, and finally the length. So the length here is how many pixels the line that I drew measures. So this can be useful, for instance, if I want to know how large this crater is, I can measure it with SalsaJ. And now the software is telling me that this crater is 78 in length. But 78 what? Miles, kilometers, centimeters, light years, megaparsecs? I don't know. The answer is that is 78 pixels, because we are seeing only pixels. So you have to convert how many kilometers a pixel with that telescope corresponds to the moon. So that would depend on the telescope, it depends on the camera. We're not going to give much details here because we want to show other things. But sometimes this information is available on the image itself. And that's another thing that is very interesting about the FITS files, is that in addition to the images that we are seeing, we can have lots of other information that is similar to metadata on normal images in our computers. So if I go on the top menu here of SalsaJ and I choose Show Info, then I have a new window popping up now that it's called the header. So the header of a FITS image is text that brings us information about that particular image. And part of this information is automatically provided by the telescope and the camera, and part of it is provided by the observer. So here we have some technical information, but also some information that was added by the observer. So in this case, the observers were Emily and Amanda Diller, and this image was taken with a very historical telescope that is the IRCS 25-inch telescope, which is, you know this telescope, Fraser? Have you ever heard of the IRCS telescope? That is the largest refractor telescope in the world. It has a lens of 1 meter. That's 24 inches, right?
Yes, it does ring a bell now. Yeah,
yeah. So this is the largest refractor in the world, is more than 100 years old, but is still operating. And it was with this telescope that this camera was taken. And in that configuration, we have some interesting information here that in that image that corresponds, each pixel corresponds to 0.6 arc seconds. So that is a measure of angle, but give us an idea. It's possible to calculate the size of the pixel in kilometers with this information, because if you know the angle and you know to the distance to the moon, that is roughly 384,000 kilometers, with simple geometry, with trigonometry, you can calculate the other side of the triangle using this information. The distance to the moon and how many arc seconds per pixel. An arc second is 1 degree divided by 3,600. Then it's possible to make this calculation and finally obtain how many kilometers a pixel corresponds in that image. Sometimes you have this value in kilometers also added to the header, but in this case, it's not the case. It's not here. And just to conclude this part of the header, we have here the date that this image was taken. So this image is also very old. It was taken in September of 2001. So that's more than 20 years ago. And also the time that was observed in universal time, what is the temperature of the detector and other things. So for every PITS image you open, you can go to the information. That's on SalsaJ, you go to the image menu and click show info, and then you have this information. For every PITS image, you have this option. So this is just to present some of the features that we have in SalsaJ. It can open images, you can make measurements, you can see data, but today we are going to do something more fun. That is to have color images. So one thing that sometimes disappoints people when they look at the astronomical images we take with the professional telescopes is that these pictures are black, white, and gray. Okay, the moon is black, white, and gray. It's not very colorful object, but if you open a different image that I'm going to open now, I'm going to show you a picture of a nebula. We are going also to see black and white. So we are now looking at another image. We don't see much here. I'm going to explain why we don't see it in a moment. But this one is called M27 red. And I also have here 2 more images of the object, the same objects that are blue and green. So now you are seeing 3 windows. One is red, one is green, and one is blue, only in the name, because they are all black, white, and gray. So what's going on? What is the blue? What is the red? What is the green? So the truth is that the astronomical cameras, they only detect light in black and white, so to say. They only register if there was light coming to that pixel or not. And the more light it comes, the brighter or the whiter that pixel is. To add color, then we need to combine images taken from the same object, but with different filters. So to make the color images, what astronomers do is that in the front of the camera, they put filters that let just light of a specific color to pass through that filter. So for instance, this red image, it only has image that is in the red. And in the blue filter is only image that is in the blue. They look black and white, but it corresponds to blue light. So to make that look blue, we have to paint this image blue, and the same for the green and same for the red. So that's what Salsa J will do for us, and that's what Fraser will do also shortly. So the first thing here is that we don't see much in the image. It's all very dark. This is because the astronomical images are very faint. And the only bright spots here we see are stars. The nebula is much fainter. So to show the nebula, again, we have to use the contrast button, the brightness. And here I'm going to be very lazy. What I can see here in this histogram is that most of the data is towards the left side of the histogram. So that is the dark side of the map. So I'm going to hit Auto, and when I do that, he sets the contrast, and then we can see finally we can see the nebula. I will do the same thing here in this second frame and the third frame. So now I have 3 images, and I can see the nebula. This is a Messier 27. It's also a very famous object that is called the Dumbbell Nebula. And this is a nebula that is we call planetary nebula. It's a dying star. This is actually how our sun will look like billions of years from now. Okay, you don't need to despair because it's going to take a very, very, very long time. Probably humankind won't be in Earth when that happens. But this is how a star like our sun, a solar type star, ends its evolution. It loses all its outer layers, and these layers they escape to space, forming this cloud. And these are very colorful objects, and we can indeed see that this, depending on the filter, there's a small difference in appearance. So this in the red filter, we have structures that are different from the green filter. So that's actually what astronomers are interested in. They want to see how the appearance of the objects and the information that comes from light change depending on the region of the electromagnetic spectrum they observe. So to turn these images into a color image, we will use Salsa J. I have the 3 frames open, and now I'm going to use a special function of Salsa J that is called the color merge. So I'm going to use again the top menu. Here is on the image option. There will be an option called color. So this is the 5th item in this menu. And when I select color, there is an option called RGB merge. So what it does is it merges, or it makes a fusion of the R, which is red, G, which is green, and B, blue images. So when I click here, I have to tell Salsa J which frame is the red, which frame is the blue, and which frame is the green. So it got the red correct, but the green and blue are mixed. So I'm going to tell that the green frame is the one that's called green, and the blue is the blue. This box here is, if you leave it selected, it will not close the previous ones. I like to do it so I can compare, but it doesn't matter. If you just forget to click it, the black windows will disappear, but the file will remain there. And then when I click OK, then magic happens. Now we have a color image of the nebula that was done using 3 black and white images, so to say. So Salsa J allows us to do that. If you have pictures of celestial objects taken in different filters, we can have a color image using this special RGB merge function. So it's as easy as that. So with Salsa J, you can easily combine pictures taken with the telescopes that, for instance, the Focus telescopes, and combine them in making a pretty picture. And this is something that I'm sure your students will enjoy. And also, if you want to save the picture, it's very easy. You can go to the file section and select save as, and then you have some formats here of how you can save this image. I can save it as a JPEG file and then send it to people, because this is a file that everyone can open, or a PNG. So these are standard image formats that all computers will be able to open. So this is about it, what I have to show for the presentation of the basic features of Salsa J. There's a lot more that we can do with Salsa J. We can measure brightness, we can make animations, we can process data. But for this webinar here, we are more interested in showing how we can make color images using telescopes. And this is how you do it. So now I'll pass the word to my colleague Fraser, who will continue the webinar with the images that we obtained last week using the Folks telescope. Actually, it was another telescope, right? The smaller one.
Yeah, it was one of the 40-centimeter ones in Australia.
40 centimeter.
Yeah.
And now I'm back on YouTube, so I will be able to answer the questions, and I will also share the link to Salsa J where you can download it. Okay, so Fraser, I have to allow you to share the screen.
Yeah, okay. I don't know if it's the case with everyone else. The video was running about 20 seconds behind the audio on occasions in that. So I will try and go quite slowly anyway. Let me share my screen, then I'll share the whole screen first of all, which will go a bit odd because look, I think I'm sharing something that I'm already looking at you guys on, so that's going to go a bit strange. Right, let me get rid of that window. Let me see what, okay. So I'm going to, okay, it says screen sharing is paused. Don't know what I did there.
Okay, stop sharing share again.
Yeah, I did, and then it didn't. So if I click resume share, it goes back to this.
See Folks telescope, now see Folks telescope again.
But if I minimize that, it stops sharing. And I don't know what I'm doing to, because I've got SalsaJ on my screen. Okay,
are you sharing the whole desktop?
Yeah, let's start. That's what I thought I was doing, but try this. Is that any better? No, it still should.
I see now the file manager.
But if I minimize that, it doesn't let me share SalsaJ, right?
No, you have to share the whole desktop.
I've done that twice.
I think you should open. Is SalsaJ open?
Yeah. So close SalsaJ and try and start from the beginning.
No. Leave it open because I see desktop. That is the desktop folder. It's not the whole desktop.
Okay, let me try one more time. Screen. There we go. How?
Yeah, I see the dog now. Yeah, you're good.
Okay, and I haven't got. So you can see the dog. Okay, right.
Yes,
that's the same. And we haven't got SalsaJ open. Okay, so let's open SalsaJ. Okay, so I'm going to open a file, and I've put all my files in a particular folder, which is called SalsaJ Images. We'll start with the ones from last week. We'll have a look at these. I'll show you one of the ones I took last week was of a star-forming region called 30 Doradus. It's also known as the Tarantula Nebula. Okay, what you can probably see, and this for the first time in it's this afternoon, this isn't a mistake. I genuinely do see a black image, and I genuinely expected to. This is the same sort of idea that Gustavo was saying before. Sometimes when you open SalsaJ, it doesn't know exactly what you want to do with the image, right? It's only a computer program. So we have to sort of tell it what we want to do. And the way to do that is image and adjust and brightness. And then we get this little window up here on the left-hand side. And as Gustavo was saying, Gustavo uses the lazy way. And I'm all in favor of that, but let's try the other way just for fun. And I'm going to drag the red line. Hopefully you can see it on your screens up to about there. And then I'm going to drag the blue line. Now I'm dragging the blue line back. So the interesting area on the screen is that black sort of graph or that black sort of set of lines in the middle. And I've got a red line and a blue line. And as I get my red line and blue line quite close, so the image starts to sort of appear. Like I say, the auto will generally work as well. Sometimes this one you can use to just fine tune a little bit. And that's roughly, I mean, that's not too bad there. This is an image taken with the green filter. As Gustavo was explaining before, that doesn't mean it's green. It just collects green light. It goes through a green piece of glass, but it's still a black, or it's still a set of white stars on a black image. That's not a bad image. That's not too bad at all. I'm going to open the other two as well. So there's one in R, the red filter, and it'll open as well. And we'll do the same thing. Let's do auto this time, just because we think it's a little bit quicker. Okay, that's not too bad. It doesn't really match the other one. And in fact, you could argue maybe this one's better because the black sky is very, very much darker. So maybe that's not so bad. Maybe we should try that with the G one as well. See what auto does. Yeah, you know, I think you can get a little bit more detail than that just by playing around with the faders. This comes with time. I'm not brilliant at this. I really had to try and remember how to do this yesterday. So this is not that difficult to do. Your students will do this very, very quickly because it's just pressing buttons and playing around with things. And we want to open one more image, which is the I-band image. Now, let me just open that. Same sort of thing appears. It's not brilliant, but we can click auto and we get a little bit better. And then we can kind of just play around with the faders a bit, and we can see sort of features there. So you can see sort of a really bright area of star, lots of very, very bright stars crowded together in the middle, and then this kind of wispy gas and dust that is around it. Somewhere around about there is maybe the sweet spot. Let me explain. I said here GR and I. My filters are GR and I. Now, maybe that doesn't mean a lot to you. In astronomy, we normally talk about BV and R or BG and R. So blue, green, and red, or blue visible, which is green, and red. The filters we're using here are a little bit shifted towards the red part of the spectrum. So we're actually using green, red, and then we're using a filter called I. It's not quite infrared, it's nearly infrared. It's about as red as you can go in the optical. So it's redder than red, if that makes sense. So we're still combining three images, but we're kind of playing around in a slightly different part of the spectrum. Gustavo was showing before how to do this, and I just wanted to see whether it does it or not, because we do color and RGB merge, and it guesses that red is G, green is R, and blue is I. That's kind of the wrong way around. But you know what? We're not really being scientists here. We're somewhere between science and art, right? I mean, we're already playing around with, well, what looks good to me, and maybe what looks good to me doesn't quite match what looks good to Gustavo, and so on. So there's already a little bit of artistry going on. But what I'm going to do, our filters go from G to R to I. So I'm going to make the blue one G, the green one R, and the red one I. Think that's about right. We'll keep the source images. We'll click on OK. And we get an image that looks a bit like that, which is, you know what, it's not perfect. One of the things I noticed there, let me expand that for the full screen, or at least to that point of the screen. Didn't like that. There we go. One of the things you can probably see, there's what we might call a misalignment. If I drag my cursor down to a star, hopefully you can see there's a cross on the screen. This star by my cross there, it's not really very white. There's kind of a white bit and a red bit and so on. This is because the telescope has moved just an absolute fraction, a tiny, tiny little bit between one image and the next image. And I haven't accounted for that. We can, not sure I can do it today, but we can go back and reset that so we can actually move these images and get them sitting on top of each other a bit more neatly. It takes a little bit of playing around, but again, your students will find their way around that very, very easily. So there is some color in this image. We have sort of produced some color. It's got a bit of a blue hint to it. It's not the best example. I don't know what the reasons are. There are two reasons in my mind where I think that might be. One is that we're using a filter set that is slightly different. This sort of red, green, and blue filter set that we're more used to will potentially do a better job. And the other thing is, to be honest, 30 Doradus, it's a star forming region. It's got lots of very, very bright white stars, very hot stars that are sort of bluish, bluey white. So there's not loads of color in this image to bring out. So I'm kind of struggling to sort of bring out much more than that. I did have a look at the other images that we had last week. Let me show you the images anyway, just because I think they're quite nice. So not really so much to do the color processing, but just to show you again, we looked last week at M42, which is the Orion Nebula. Again, when we open the image, it looks a bit like that. We can click on auto and we start to get somewhere straight away. And whoop, there we go. There's a bit of fine tuning going on here. You need to have a steady hand. But you can see there maybe again, this is a star forming region. There's lots and lots of bright stars, and all this kind of wispy material around it is the dust that goes to form the nebula. This is the nebula that the stars are actually being born in. So this is the Orion Nebula. So I wanted to show you that image because it's quite a nice image. Color-wise, it didn't bring out loads, but we'll come back and show you a couple of others that do. The other one we took last week, I didn't really get to see anything sensible in there. I don't know if we missed the object or I just used the wrong exposure time. But what I will show you, because I appreciate one thing we're doing here is we're just sort of grabbing images. So like Gustavo showed you before, there is another planetary nebula. So Gustavo showed you M27, which is the Dumbbell Nebula. This one is called the Ring Nebula. Now, if I go to Window and Tile, it actually places the three images across the screen. And you could probably argue straight away that you can see the Ring Nebula in two of them and maybe not so much in the red one here. Let me move these around. So I'm going to move this one over here and move this one there. The only reason for doing that, not telling the computer to do anything, they're now sitting on my screen as blue, green, red. We need to do something with the red one. I think we can safely say that the red one is not brilliant. So let's drag the brightness little window. SalsaJ opens lots of different windows, and you always end up finding one hiding behind everything else. Let's see if we can do this one here. So at some point, we start to see the nebula. Okay, we're not doing a great job here. That to me, okay, I was just going to say I got it right, and then I let go of the cursor. That's about right. We sometimes play this game. One of the images just doesn't look quite as nice as the others, but those three are reasonably okay. If we go to Image and Color and RGB Merge, Salsa J does its best guess again, and it thinks that red should be the blue fit, green should be the red fit, and blue should be the green fit. And sometimes you wonder why it doesn't quite realize what you want to do straight away. And again, although I'm assigning these colors, there's a little bit of kind of artistic license. There's a bit of false color going on here. I can choose to do this the other way around. This to me, red being red, green being green, blue being blue, as a scientist, that feels right. But you know, it doesn't have to be that way. We'll keep the source images. We'll click on OK. You know what? I'm going to say that's pretty good.
That's not bad.
It's not bad, is it? There are a few red stars in there that are a little bit too red, but the actual image of M57 here is pretty nice. If you Google M57, I won't do it, but I challenge you to have a look at it. You will find objects that look pretty much like that. So that's not a bad data set. I promise you, I didn't really do anything particularly clever. You saw the button presses I did. And again, we can go back and we can look at this and say, okay, maybe it's not got enough blue. And we can kind of go back to the original image, dial up the blue a little bit and recombine them and play around. So there's always ways of sort of just revisiting this. And as I say, some of your students will really appreciate that side of things. So that's M57. And the other one I'm going to try. Actually, I was going to say about this image, in very, very broad terms, when we see red in an image, this kind of image, it starts to suggest hydrogen alpha. And when we see green, that starts to suggest oxygen. And as Gustavo mentioned before, we think this is a star, a bit like our sun. This was a star that is, I get my tenses wrong. Our sun will go through this phase eventually. So this is a star that was like our sun, has sort of lived to the end of its life and has lost its outer layers. And we think that the outer layers of a star would be mostly hydrogen. There will be some processed material towards the center of the star, which would most likely be oxygen and helium that wouldn't have been processed, maybe bits of carbon and nitrogen. So seeing red and green here starts to suggest hydrogen and oxygen, and that sort of ties in with our theories about how stars create, or how stars liberate energy, and what elements they create as they're doing so. So that's a nice one there. I will show you this in a minute. What I will do is I'll show you where I'm getting this data from, because it's one thing to kind of show you what Gustavo and I can do with the data, but I don't think that's as important as showing you where you can get hold of the data and then play around with this yourselves. I think that's a far nicer, or a good endpoint for us today, would be to do that. Okay, so again, we start off with 3 images. We have a blue, a red, and a visual. You know what? I think it's doing this alphabetically. So there we go. So there we go. Those ones. We're going to try and set up the brightness here for these images and see if we can find an object in there. You might have seen the file name, which would give you a clue as to what it was, or the folder. But you can see there. There. Oh no, nearly got it. Nearly got it. Like I say, you need a steady hand to do this. And I clearly don't have a steady hand. Round about there, we've got a couple of stars there that are very bright, that have almost saturated the image, which makes it tricky to find a perfect point. But you may start to recognize that image, or that object on the right-hand side, as being what we call M16, or the Eagle Nebula, the Pillars of Creation. Again, a star-forming region. This is a place where stars are being born. In the constellation, I think, of Serpens. Let's have a look at the green image. I was playing around with these earlier, and I was very successful at pulling out the detail, or some of the detail at least, in the green and red images. It's round about there, isn't it? And I think the blue one I had an absolute nightmare with. So let me see if I can produce the blue one with an audience better than I can do it when I was trying to do it myself. It's, do you know, it's round about there. Okay, those images, the stars are very blobby. I appreciate that they're not ideal. But yeah,
That's too dark, yeah.
It's too dark.
My experience is that the background level, the dark, should be the same in the 3 images. Otherwise, the filter will. I think that's what's happening in the first image in the Tarantula Nebula. But that one of the filters are
okay.
I
so
think like this is fine. Yeah. Let's try.
And again, I promise you, I am absolutely not an expert on this, and there are some people out there that can do some really, really good things with these images. You can, of course, disappear off into things like Photoshop if you have access to that. SalsaJ obviously is the free version of doing some of what you can do with Photoshop, which is why we're happy or we're keen to share it with you. Yeah, that. Yeah, it's a bit blue, isn't it? You got those stars that are so bright in the blue image are a bit too. But let's see if we can change it. So let's try and make this image a bit. Oh, I'm on the wrong one. Hang on.
Either you make the blue darker or the other ones brighter to compensate.
Yeah. So
the good thing is that you can play this as much as you want.
Absolutely, yeah. I mean, what we're not doing here, in a sense, is we're not editing the original images. We're just grabbing them and playing around with them. So yeah, you can go back and revisit this as many times as you want. I've clicked a couple of buttons there, and we'll see again. Okay, I need to tell it the right way around. Keep those. Okay,
Oh.
so what was too blue before is probably now too green. And of course, the green is coming from the middle image. So we can go back and you know, I don't want to spend hours, I probably am going to spend hours doing this now, even after we finish talking to you. But I don't want to spend hours really pushing the point too much. But okay, I've dropped the green down a bit and we'll see where that takes us. This is the last one I'll try on this, I promise. But I'll share with you some resources in a second as well, just so you can do it yourself. Yeah, I mean, yeah. There are people out there that can do better than that, or almost everybody, Gustavo, right? But that's okay. I mean, that's not too bad. Let me share with you some resources. So I'm on a page here, which is the old, so Falk's Telescope project. We provide the telescope time, we provide all the background information on what objects to image and so on. We do provide some information about astronomical images. So if I click on astronomical imaging here, I'll put the web link in the YouTube unless Gustavo has already done it. If you click on astronomical imaging, there is some information here on animations. There is basic color imaging, advanced color imaging, and other techniques. Let's click on basic. And there are lots of different things that you can do here with different animations, and there are instructions down the bottom here how to make color images with Salsa J, with Photoshop, and with some other programs as well. In here, there are 6 data sets, and these are data sets that we think will generally produce quite nice images. So M16 is the one I just looked at. M51 is the Whirlpool Galaxy. M57 is the first one I showed you, the Ring Nebula, that was very easy to produce that. There's the Black Eye Galaxy. There is Centaurus A, which is a galaxy, and there is NGC 5195, which is another galaxy near M51. So we've given you here 6 data sets. Each of these data sets contains 3 images, the red, the green, and the blue. And you can download these. Each of these files is probably a few megabytes, so hopefully it shouldn't take too long to download. And there is lots of information. Again, yeah, we're not here necessarily today for me to try and sell Falk's Telescope too much, but have a look around the resources. There is lots and lots and lots of stuff, and this is really only just one aspect of of what you can do with the images, and of course with Salsa J. The other part of this I'll show you, and Gustavo, I know you've been involved in this as well, so I think it's nice we can share this with you. Our old website, the one I just showed you, has got too much on it by a factor of probably about 10. It's got too many things, too many different sets of instructions, bits of data that we've built up probably over about 18 years or so, even 19 years now that we've been up and running. As a result of that, we decided to try and recreate our resources page in a little bit of a nicer format. So again, I'll try and make sure you get this link. This is the new resources page, if you like. And if we click on resources here on the right-hand side, there is a folder called astronomical imaging, and that will then tell you how or what FITS files are, which is something Gustavo mentioned about 45 minutes or so ago, towards the beginning of the session. It talks about different software. Salsa J is one that we recommend. Like I say, we've been using it for a while, and our data works very well with it, but there are other sets of programs that do aspects of what Salsa J does as well. So there's an article here on Salsa J. We have some videos that you can link to on YouTube. So if you like your instructions in video form, that's great. If you prefer them in sort of PDF form, there's a PDF version of the documentation here as well. So hopefully, again, have a look around that website. If there are any things there that you can that you think are useful, then by all means use them. None of what I'm showing you today is behind a password. None of it requires you to register. None of it requires you to pay any money. This is all done and available. There are some sample files here as well for color imaging. I can't remember what these are, which is why I'm reluctant to click on them now just to see what they are. But yeah, there are different data sets here that you can download. Again, I can see M16 and M27 in here, which are the 2 that we just showed you. So it may well be a similar set of data to the ones I showed you before. Gustavo, is there anything else that you think I should share right now? appreciate we're just coming up to the hour mark, but I don't know if there's anything else that we want to try and explain
No,
today.
maybe
Or are there
if you
questions
want
coming in?
to, if you want to use this image, the 30 dorados again, you know, there's this middle frame, the one is very dark.
Do you want me to show them again?
Yes, it's open,
Okay.
right? It's the middle one.
The 30 Dorados one.
30 dorados, yes.
So you're saying all 3 frames, or did
All
you
three,
just...
yes.
Yeah.
Let's try again, because
Okay.
the first version was not very successful. You
No,
see
I
the
know.
second
Yeah.
one, the top left is too dark. So if you can adjust the free to match the same intensity level of the black.
You're saying this one is too dark.
Yeah.
Is that better?
Yes, that's better. Yes.
Oh, okay.
Now make the other two, if possible,
as similar. Yeah.
at similar. Yes. Let's see if you can get a better result. Yeah, but if no, to the other way, maybe. Almost there.
I know.
No, to the other way. Yeah.
Yeah.
That's fine. Yeah.
Gustavo is coaching me on the fly. This is there. We go. Okay. Wait.
Yeah, it's very delicate.
It's really fine sometimes that the sweet spot of getting the data.
Good. I think we have a band.
Okay.
That's fine. Yeah.
We'll try that, and we'll try image and color and RGB merge, and then we need to remember the order of this. So hang on, let me see if I can remember this. The bluest one is G, then we have R, and the reddest one is I. Click on that. Yeah,
no, it's too blue.
It's too blue. Okay, right. Well, we'll close it.
No, but it's fine. This is the Tarantula Nebula.
Yeah, absolutely. But again,
it looks more like a spider now.
Yeah.
More menacing.
Yeah, that's true. Try one more time, just because.
So the cool thing here is that you can try as many times as you want. You don't need to be afraid of losing the overwriting, because it's the original files, they are not overwritten. So you can try and mix and change settings, and then it's fun. I think that the kids like to do it. And you mentioned also Photoshop, like it's possible to do that in Photoshop, but first of all, Photoshop is not for free.
Yeah.
And second, it takes much more time to do. You get sometimes a better result that professionals use. But the good thing with Salsa J is that it's very quick to do it. It's fast, and in just a few sliders and clicks, and then you have the image. So I think it has many advantages. Yeah. But
I'm getting nowhere with this one. I'm getting nowhere.
Yeah, it's not easy. Yeah, it requires some persistence, some luck sometimes. Yeah, but I think it's every time it appears a bit different. So I think this is something nice. It's like cooking. Yeah, you cook. It's the same recipe, but
you learn. Yeah.
But every time it's something is a bit different.
And that's another nice thing with Salsa J, Gustavo. When you Google Salsa J and tutorial, you will find lots of tutorials on YouTube, or in PDF form, and you will find them in multiple languages. So if English isn't your first language, you will find that there are other people out there using Salsa J in different languages and making progress that way.
Okay, good. You have anything else to show us, Fraser?
I don't think so. No, I think that was really it in terms of the images. The ones that we got last week weren't amazing, but the other thing, of course, is we do have an archive, so we can hunt through. So it's not just last week's images. We could go onto the archive and search for 30 Dorados and find lots of data sets that other people have taken in different filters, different exposure times, different telescopes, and of course, different conditions as well. And you may find data sets there. Again, it's obviously it's quite a difficult, or can be quite a lengthy process finding the data, but yeah, it's absolutely possible to do that.
Great. Yeah, so I think this is a very fascinating activity, especially for those who are like astronomy, as many of you do, and also like working with computers, with imaging. The skills that you learn by doing this, they can also be valuable for other kinds of image work, photos and other things. It's quite useful. You learn a lot by doing it, and the best thing is for free. So you can download SalsaJ and use with many things. You can use pictures that you take with your cell phone and also open SalsaJ and play with them. So there's really, it's a very powerful and very such a small software. I know it's not even 20 megabytes, the executable, it's so powerful. And yeah, so that's why we love it so much. So Fraser, so thank you for being here with us again.
Oh, you're welcome. Thank you for the invite, and thanks everyone for watching and making comments as well.
Yeah, so I'm looking here at the chat on YouTube. There's a comment here by Mr. Ansari. My experience, if you get a decent image, you can export it and play it around with the colors on your iPhone. Yes, definitely. You can post-process it. First you use SalsaJ to combine the images, the fits files in the filters, and then you have a color image. But of course, you can continue processing it using whatever you like. You can put on Instagram and use Instagram sliders to enhance the colors, or you can use the iPhone image editor, or you can use any other software you like, Photoshop, GIMP, anything is possible. So that's the beauty of astrophotography and astroimaging, is that there's not only one recipe. There's really plenty of options plenty of ways that you can go to and explore. Good. So I hope this motivates you to use the telescopes and download the data, play with the data, and have some nice images, show it to your kids, get them interested in science, in astronomy, in science communication, in education. So I think this is the real value of these activities, to engage people and let them do something different. So I don't know if Nikos is around us, if Nikos wants to say something before we end the broadcast. But I'd like to thank everyone. So Nikos, are you here?
Yes, I only switched off my camera.
Mm-hmm.
I would like to thank you both for this wonderful webinar. I'm not a physicist, but it was really clear and fascinating for me. I want to thank you all for your participation, and I would like to ask you to keep alert for the next webinars, and you can be informed on the list of webinars of the Learning from the Extreme project from our social media and our website. Again, thank you both.
Thank you. Our pleasure. And you can count with us for more things to come. We are planning to have more activities here on the framework of learning from the extremes. But for the moment, we have the webinars, and we'll be back next Wednesday at the same time in the YouTube channel of Learning from the Extremes. So we will meet again next week at 1600 UTC. I just want to see here what will be the next topic, but you can register for the webinar to receive the link. So please register. It's important for us to know who you are, how can we contact you, how you can participate in the project. So it's very important that you register for all the webinars. So Nicholas, you remember what is the next session? I'm looking here. No, you don't. That is the list. I can find it, but okay, title of Planet Webinars, I found it. Okay, so the next one will be actually, yes, March 15th, so next Wednesday at 1600 UTC, using CET, that's 1500 UTC. It's learning from the extremes community, online tools and services. So I hope to meet you all again next Wednesday. And thank you for being with us. So see you soon. And yeah, bye-bye.
Thanks, everyone. Bye.